Okay, Assalamualaikum dan selamat pagi, good morning pada semua. Today, hari ni hari Khamis 31 hari bulan March, and we are joining today pagi ni for our first, boleh dikatakanlah the first tutorial session. And for the first tutorial session ni, apa yang kita akan bincang will be discussing lebih kepada the project work that has been assigned to each group. Okay. Jadi pertama sekali, first thing I would like to ask is, have you all formed your own groups for your RC2 project? Anyone? Dah ada kumpulan ke ataupun masih belum ada kumpulan lagi?
Dah.
Dah okay.
Dah, Doktor.
Right, good. So Azam dan juga Senita kata dah ada. Cuma ketua kelas, head of the class representative Kelana kan? Is it Kelana?
Betul, Doktor.
Okay, Kelana. Okay, nanti tolong please compile the names lah of all the groupings dan share dengan saya. Just for me to keep track who is in which group. Okay, so each group should have a maximum of around 4 students lah. Kalau boleh jangan lebih lah, around 4 students. And today kita akan bincang what you need to do in your RC project, right? Okay, another thing is that hopefully each one of you have already downloaded the project that is in your e-learning. Okay, I'm sharing this. Okay, this is the new share. Okay, so this is the new share, right? So this is the project that has been given kepada all sections sebenarnya. RC2 section, we have 3 different sections, section 1, 2 and 3. So all the 3 sections are using the same building ataupun referring to the same building that we are going to use as our RC2 project. So the building consists of basically, kalau siapa yang belum tengok tu, basically a building which is a school building, bangunan sekolah. It is a 2-story building, and what is given sebenarnya is a plan view. Okay? Plan view indicating the ground floor plan. This is one drawing. Kemudian we have the first floor plan, okay, aras tingkat 1, plan tingkat 1, indicating again the layout of the building for the first floor plan. And finally we at the roof plan. Okay, we have the roof plan. So it is a ground floor, first floor, and then roof. Berwarna kalau kita tengok, if we take a look at the cross section of the building, indicating that the building is a 2-story building. We have the lower floor, the ground floor, indicated di sini, and okay, we have the ground floor di sini. This is our ground floor, and this will be our first floor, and finally our roof level. Okay, so it is relatively not too complicated. It is a 2-story building, and we have the front elevation and the rear, the side elevation. Okay, the front and the side elevation indicated di sini. And finally, we have a typical cross section of the building, indicating the the non-structural components lah sebenarnya, indicating the overall height of the building dan sebagainya. So this is the basic drawing, the architectural, bolehlah dikatakan sebagai the architectural drawing for a 2-story school, bangunan sekolah, bangunan sekolah. And because the indication is that we have a classroom punya arrangement di sini. Okay? So we can safely say that the building is a school, a 2-story school, bangunan sekolah 2 tingkat. Okay? Right. Cuma the shape of the building is like a U shape sikit lah. It is, we have one apa nama, on one side sini, kemudian we have another block di sini, and subsequently we have another block over here. So it forms like a U shape punya building, okay, for a two-story building, U shape. Okay, so this is basically the architectural drawings that I have shared with all in your e-learning. So please download the drawing, and from this architectural drawing, and then apa nama, each group will will then attempt to design the building. Okay, design the building ni nanti kita akan will have a look at that later on. Before designing the building, biasanya is to come up with your structural plan. Okay, your structural plan. For those yang during your intern, you were fortunate enough to apa nama, to be involved in maybe some structural design during your intern. Okay, so you are well aware of what is meant by a structural plan, ataupun setengah-setengah tu katakan framing plan. Okay, so a framing ataupun a structural plan is basically a plan in terms of because what we see here is basically architectural punya architectural punya features, mainly the type of spaces ataupun ruang-ruang yang diberikan, okay, the arrangement of the space within the building, the function of the building, which is indicated as a school building. Okay, so these are some of the information yang kita extract from architectural drawings. Apart from that, dimensions, okay, dimensions of the building, the overall general dimensions. Contohnya, we can see from one grid to another grid, what is the dimension given di sini. Okay, if I'm not mistaken, from one grid to another grid is approximately 9 meter, about 9 meters. Okay, so this is the grid. We have a numerical grid on the vertical section. Okay, we have starting from grid number 1 sampailah grid number 7 on one side, the longer side, and on the shorter side we have a alphabetical punya grid A, B, C dan seterusnya until F. Okay, so we can say that the building is very symmetrical about C and D. Between C and D itu is a symmetrical between C and D. Okay, so other architectural information yang boleh kita extract is that there is indication of staircases. Okay, if I'm not mistaken, ada 4 tangga. We have staircase number 1, staircase number 2, and further down at the end of the building, we have another staircase. Staircase, I think this is staircase number 3, and finally, on the opposite side of that, we have staircase number 4. So basically, there are 4 staircases. So meaning each group member can tackle one staircase, even though it might be the same, kan? So these are the information that we can extract daripada the architectural drawing. Another important aspect that we can try to understand from the architectural drawing is that apart from the dimensions, okay, this particular architectural drawing clearly indicates column position to be located within the building. Okay, usually some architects would not would not indicate where the columns for the building should be, because the position of columns is usually determined by the structural engineer. Tapi in this particular case, we see that the architectural drawing has clearly indicated what we see as our square, apa nama, black square di sini, okay, petak hitam ni. This clearly indicates that this is the position of columns that the architect wishes the structural engineer to use, okay, to locate the columns as per the architectural drawing. Now the reason for that might be, kalau kita tengok kepada the front ataupun the rear elevation, okay, we can see clearly, okay, that this particular component yang kita nampak ni, a vertical component, okay, so the architect in this particular project would want the column to be part of the architectural features. And that is why the architect has indicated he wants the column to be in certain position, because the columns will then be part of the architectural punya features. Meaning to say, if we were to look at the side elevation of the building, we would be able to clearly see the column position located ataupun indicated in the architectural drawing. So from here we can clearly understand why the architect has located certain columns at certain position, particular position, because the columns forms part of their punya architectural punya feature. Okay, so the architect wants the columns to be part of the architectural feature. Okay, jadi kalau if architects did not indicate any column position, therefore we can summarize that the architect is not using the column as part of the punya architectural feature. But in this particular case, by by locating the columns in the architectural drawing, it means that the architect wants the column to appear as part of the architectural features ataupun architectural features dalam bangunan tersebut for that particular building. And that is the reason why we see in this elevation, side elevation, clearly we can see that these are the architectural punya, these are the columns that will form the architectural finishes, okay? Part of the architectural punya features for the building. So that is the reason why the architect is controlling the location of the columns. So in that sense, the architect has already indicated dalam drawings where the columns should be. So the purpose is basically because the column will then form part of the final finish of the building. So by looking at this elevation, we can understand why. Okay, we can understand why column positions are clearly indicated dalam drawing. Okay, in the architectural punya drawings. Okay. So back kepada kita punya floor plan, okay, typical floor plan. This is our typical first floor, ground floor plan. So this black squares, okay, these black squares indicate the position of columns. So it makes us a bit much more easier lah, because the architect has proposed certain column position, and to our observation, the column positions are reasonably spaced. Okay, reasonably spaced ni meaning that the columns are not too close together and not too far apart. Okay, we all know that columns ni act as support for the beams. So indirectly, by having columns terlalu rapat, too close, it means the span of the beam will be very short. Okay. On the other hand, if the columns are placed maybe 10, 12 meters apart, center to center column is about, katalah, let's say it's about 12 meters, then this will translate as the span of beams would then be about 10 to 12 meters. So the position of columns indirectly indicates the span of beams. Indirectly, secara tak langsung, it will form ataupun it will control the span of the beam. If the columns are too close, then the span between the span of beams would be very short. If the columns are too far apart, then kita katakan the span of beams will be too big. Okay, terlalu besar span dia. So what we see here is that the columns, the biggest distance between columns is approximately 7.5 meters. Okay, so my experience, kata pengalaman saya, column position space between anywhere between 6 to 8 meters, antara 6 hingga 8 meter, is a relatively suitable punya position, not too far apart and not too close. Okay, jadi between 6 to 8 meters is a relatively comfortable punya position ataupun spacing between columns. We have about 7.5 meters. This is the biggest span ataupun the longest span between columns. Between in this direction we have about 6 meters. Okay, and this is about again 6 meters, and 7.5 is the biggest ataupun the biggest center to center, the biggest distance between columns. On the numerical punya grid, we can have a look at some of the columns are spaced at 6 meters, whereas the regular interval shown di sini is approximately 4.5 meters. Now that is a bit too close, tapi tak apalah. It's still manageable. 4.5 meter span of a beam. Okay, so we would expect that beams spanning between these two columns will have about 4.5 meter span, and this one between these two columns would have a 6 meter span. So indirectly, the position of columns will dictate the span of beams. Okay, and satu lagi is that we can see that the location of the columns is in line. Okay, in line with the brick wall location. Okay, so we can safely say that if this is, let's say, this is the column position for this particular building, then for me to put up a beam, okay, where I want to put up a beam, okay, let's say di sini, maka I can easily locate my beams to be a continuous beam in this position, for example, where this continuous beam would then be supported by columns, okay, by columns yang inilah, by columns indicated di sini. We have one column di sini. We have another column here, okay, another column here, okay, column lagi di sini, and over here, and finally we have a column at the end of the beam. So indirectly, the position of columns is in line dalam satu garisan that is relative to each other, and this would make it much easier to provide beams. Okay, so by looking at this architectural drawing, sebenarnya a lot of information we can extract. Pertama sekali, as we have said earlier, the use and kegunaan bangunan, the use of the building, the function of the building, the finishes related kepada building, even though di sini tak ada tunjuk exactly finishes. Usually kalau the full architectural drawing, okay, then we will be able to see what are the finishes that is used for the building overall. Okay, location of staircases is one more information that we can extract from the architectural drawing. However, in this architectural drawing, the R and G values, kalau if you remember, we were talking a lot about R and G values for staircase, okay? R dengan G values for staircase design. So R and G values are not clearly indicated. So you need to evaluate and you need to calculate what would be the R and G values. Nanti kita akan sentuh sikit lah, saya akan sentuh sikit on how to obtain the R and G. We have our general guide. Remember dalam our notes on staircase, there is a formula given where a combination of R dengan G2 should be within a certain range, kan? So we can make use of that for a public building to guide ataupun to obtain some dimensions of R and G. Okay, so this is the basic architectural drawing. Apart from the information yang that we've been discussing, satu lagi, if we take a look at the cross section of the building, which is indicated di sini. This is the cross section of the building. Okay, a typical cross section is shown here di sini, and a typical cross section indicates that if we look properly, the ground floor di sini, this particular ground floor, is a floor that is raised from the original ground level. So the ground level is somewhere at 0.0, okay, relatively at 0.0, and the ground floor is then raised up by as much as 450 mm, okay, 450 mm. So the ground floor is a raised ground floor yang slightly higher than the ground level around the building. So this very important indication ataupun information that we can extract di sini is that we can safely say that for the design of the ground floor for this particular building, we would design the ground floor as a suspended ground floor, meaning the ground floor to be suspended ataupun to be supported by beams. Now ground floor ni usually usually there are two approaches to design the ground floor. One approach is to design as a non-suspended ground slab, and the other one is to design as a suspended ground slab. So if we look at what is meant by suspended dengan non-suspended ground slab ni, okay, looking at the more typical ataupun the more usual type of construction adopted usually is where we have the non-suspended ground slab. What it means is that in the construction of the non-suspended ground slab, the ground beams will be constructed first. The ground beams will be constructed, meaning the reinforcement for the ground beams together with the shear links for the ground beams are put into place, and concrete is poured for the full height of the ground beam. Let's say this is our ground beam. Okay, this is our ground beam, and concreting is done for the full depth of the ground beam. So this is the full depth of the ground beam. Then what it does is what the builders ataupun constructors will do is to excavate on the inside of the ground beam and put in what is termed sebagai kita punya hardcore filling. Okay. So we would most probably see a lot of aggregates, okay, of various sizes, okay, fill up on the inside of the ground beam. This is termed sebagai kita punya hardcore layer, hardcore layer. This is usually consists of aggregates of various sizes, okay, and poured into the ataupun put into the sides of the beams ataupun overall on the underneath of the slab, proposed slab, and compacted. Okay, so it is a compacted hardcore layer, compacted using hand compactors. Compacted. For those yang again referring to your intern, okay, you might have come across some activities on site where they were compacting hardcore layers. So this is the compacted hardcore layer, consisting of aggregates of various sizes. Okay, ada yang besar, ada yang kecil, so that they fill up as much as possible the voids between the aggregates. And finally, a sand blinding layer, maybe a sand blinding layer of approximately maybe about 100 mm thick ataupun 50 mm thick sand blinding. Oh sorry, silap. Sand blinding ni just nipis je, tak tebal. Okay. A sand blinding layer. We have a sand blinding layer of maybe 50 mm thick. This is called the sand blinding. Okay. Sand blinding. Sand blinding layer, maybe about 50 mm thick. Okay. 50 mm thick. The compacted hardcore is usually about maybe around 100 to maybe about 150 mm, okay, to maybe about 300 mm thick, okay, for the compacted hardcore layer. And then we have a sand blinding layer. And finally what we do is, what is done on site is that the reinforcement is now placed, okay, it's now placed at the reinforcement for the slab, okay, reinforcement untuk slab is now placed, and the reinforcement for this non-suspended is usually at the top layer, okay, single layer, usually apa yang kita guna, what is used on site is a mesh, okay, RC mesh as the reinforcement for the ground slab. And finally, concreting for the ground slab is carried out. Finally, we we do the concreting part of the ground slab, and this is concreted, and this is then concreted, concreting for the ground slab. So there is a distinction between concreting for the ground beams and concreting for the ground slab. There are two separate concreting activities. We first concrete the ground beam together with all the reinforcement to the full depth of the beam, ground beams, and then compaction of hardcore and sand blinding layer is laid, and finally we have the reinforcement of the ground slab, and finally we have the concreting for the ground slab. So the green portion is actually the concreting for the ground slab. Concreting of ground slab. So this is a typical non-suspended construction where there is no physical connection between the ground slab and the ground beam, which means to say the implication of this sort of arrangement for the ground slab construction, whatever loads acting on the ground slab is transferred directly to the soil. Okay, is transferred directly to the soil below. So the soil is actually supporting the ground slab, not the ground beams, tetapi the soil together with the compacted hardcore and the layer of soil below the compacted hardcore. That is the components that are supporting the loading on the ground slab itself. So all loadings on the ground slab, whatever loads our design load might be in kilonewton per square meter, all these loads will then be transferred directly to the soil. Okay, so this is a typical non-suspended ground slab construction, and usually this sort of construction is adopted for good bearing capacity soil that is with a high bearing capacity, or typically for cut areas. Okay, previously in your IDP 1 kan, you have your cut and fill area. Certain parts of the development is cut area, certain parts are fill area. So this sort of construction is very much suitable for cut areas sahaja, where the soil is considered as a good soil. It is a hard, good soil. Okay, tanah yang keras, tanah yang bagus with high bearing capacity, and therefore there is less possibility of settlement. Remember, settlement is part of soil punya characteristic, settlement of the soil. So for non-suspended ground slab, we need to have good soil, meaning that when the load is transferred to the soil would not settle. Because if the soil starts to settle, then the ground slab will also start to settle. Because there is no physical link between the concrete beams dengan the concrete ground beam and the concrete ground slab. There is no physical link. Okay? There is no physical reinforcement that is connecting between the ground beams dengan the ground slab. So it means that these are two separate entities. We have one ground beam, we have one ground slab, and the ground beam and ground slab is not attached secara physical. So all loadings on the ground slab is then transferred kepada the soil, and the most problematic feature ataupun issue with non-suspended ground slab is the ground slab settlement. So if we have a good soil, tanah yang bagus, we have area of cutting, and the slab, the building is to be built on cut area ataupun tanah yang dipotong, then we would safely say non-suspended ground slab would be a reasonable punya solution, and it is a very economical punya solution. It is a very economical solution, is in a sense that loading from the slab is not transferred pada ground beams, because if we transfer the loads to the ground beams, then the ground beams will carry the loads to the foundation, and the foundation will have to support loadings from the ground slab. Tapi in non-suspended cases is whereby we have our loadings supported directly by the slab, by the soil below. Tanah yang support the ground. But the problem is settlement. So if it is a field area, then it is advisable not to use non-suspended ground slab construction. So this is what we term sebagai as a non-suspended ground slab. Okay, non-suspended ground slab. Where the most important aspect is that the loads acting on the slab is then transferred directly to the soil. The slab and the ground beam are not physically connected to each other, and there is a possibility, there is a risk involved in a sense that if there is any settlement on the soil, if the soil starts to settle, then this would affect the ground slab, whereby the ground slab will also start to settle. So this is one very risky punya solution lah. Unless we are dealing with very good soil. Okay? Unless we are dealing with very good soil, tanah yang sangat bagus, it is from a cut area, generally from a cut area, then we can simply use this as one of the solution, non-suspended ground slab. Another solution, okay, I'll save this. Another solution is the suspended ground slab solution, okay, which is suspended, okay, which behaves very much similar to our normal first, second, third floor punya slabs, suspended ground slab. Now, how this is done on site is usually, again, we have our ground beams. This is our ground beam. Sorry. This is our ground beam. Okay, this is my ground beam, and I have my reinforcement in the ground beam. These are the reinforcement, the main reinforcement. Okay, reinforcement in the ground beam. I have my reinforcement in my ground beam already in place. Everything is in place. My shear links, kemudian my reinforcement top bar, okay, top hanger bar, kemudian I have my bottom tension steel dan sebagainya, AS dengan top bar hanger bars. I have that in place. Okay, what I do now is that, let's say this is the level for the ground slab level. Okay. This will be the thickness of the ground slab. Somewhere it hasn't been constructed yet. Okay. We have our thickness of the ground slab located somewhere di sini, okay, indicated here. So what we do is we will start pouring concrete. Concreting will be done, will be carried out, tetapi sehingga soffit of the ground slab sahaja, not the full depth of the beam. So we will do concreting. Part of the beam will be concreted right until the soffit ataupun sampai the level below the ground slab. So we'll do the concreting up to that level dulu. Okay, and then similar to our previous punya detailing, we'll be putting in the hardcore layer. Okay, hardcore layer, compacted hardcore layer pada below the slab level, and we will also have our sand blinding layer. Okay. Sand blinding layer located somewhere di sini. Okay. And then kita akan masukkan reinforcement. Now we put in the reinforcement for the slab. Okay. Okay, reinforcement for the slab. I'm looking at a typical punya ni, meaning that I will have reinforcement, top reinforcement for the slab. This is at the support, and then I will have bottom reinforcement for the slab. So I will have top and bottom reinforcement very similar kepada normal slab punya design. Okay, and then when everything is in place, I will then proceed dengan concreting second stage. I'll do the second stage concreting, where my second stage concreting will cover the ground slab together with the portion of the beam yang sebelah atas tadi, that is left. unconcreted. Okay. Then it follows through. This will now be my concreting for the second stage. So I have a two-stage concreting technique. The first stage is that the ground beam is concreted. Pouring of concrete is until the soffit of the ground slab, then the stop, and then all these hardcore and the sand blinding layer is put into place, and then the reinforcement for the ground slab located di sini, indicated di sini, and finally this would be my second stage concreting. Second stage. Previously this was my first stage. This was the first stage punya concreting. Okay, this is now considered as a suspended ground slab, meaning that now whatever loading acting on the ground slab, whatever loading, this loading will be transferred kepada ground beam, and then the ground beam will transfer the load for the foundation, and foundation will support the load. Okay, so there will be no transfer of load from the ground slab kepada to the soil below. So it means to say that whatever happens to the soil di bawah ni, if the soil starts to settle di sini, if the soil starts to settle after 5 years, after 7 years, after 10 years, the soil starts to settle, then it would not affect the ground slab because the ground slab is connected kepada ground beam. Okay? Concreting for the ground beam dengan ground slab is in a single is in a two-stage cast in situ concreting. We have reinforcement going through the beams into the slab as our typical slab construction, normal slab construction. Cuma is that concreting is done in two stages. The first stage is to concrete the ground beams up to a level below the ground slab level ataupun the soffit of the ground slab, stop di situ, and then put the reinforcement, put in the hardcore layer, everything. Lepas tu baru second stage concreting, and the second stage concreting not only the ground slab tetapi the portion of the ground beam which has been left unconcreted earlier. So in this stage now, in this case, what we have is a suspended ground slab, in the sense that it will behave as a typical slab at level number 1, level number 2, at the upper floors, macam from a typical slab yang biasa. Loadings on the ground beam, on the ground slab will then be transferred kepada ground beam because now the ground beam is supporting the ground slab. Previously, the ground beam was not connected kepada, there is no physical connection, even the reinforcement stop di sini. So there is no physical connection between the ground beam dengan ground slab, indicating that whatever loading on the ground slab is transferred directly to the soil below. It is not transferred to the ground beam. The ground beam is not supporting the ground slab. In the second case, where we have a suspended ground slab, now we have a case of the ground beam supporting the ground slab. It behaves very similar to a normal T section ataupun the design of the beam is a relatively T section and so on. Kalau yang ini, the design of beam is just a rectangular section. Now for this, if the ground slab is assumed to be a suspended ground slab, then the design of this beam falls under T beam, flash beam punya design, T beams ataupun L beams and so on. Okay, so this is the main difference between suspended and non-suspended ground slab. We have less than 1 minute. We'll take a break, okay, 5 to 10 minutes, and we'll rejoin again, right? So if you have any question, nanti lepas ni we'll open for Q&A, and at the same time we'll have a look at the drawings. We just had a look tadi on the floor plan sahaja, okay, floor plan and the cross section of the building, okay. So I'll stop for a while di sini, and we'll continue in about maybe about 10 minutes lah, 10 minutes break, okay.